Welcome, everyone. We begin Chapter 1, which is titled An Introduction to Statistics. And in particular here, we're going to just dive in with one purpose of statistics is to answer research questions. So research is conducted to answer some type of research question. For example, number 1, what percentage of Americans support stricter gun laws? Or number 2, on average, how much sleep do college students get each night? So my little sleeping dude here is not because I'm hoping to put you to sleep, but I am hoping that you get adequate sleep. And if I did want to study college students and how much sleep they get, we could even go further and try to research how does maybe lack of sleep affect academic performance. So all sorts of things we could study regarding college students and sleep. So the next thing we'll do here is define our population. So the population will consist of all members of a specified group. So if I'm interested in Americans that support stricter gun laws, my population would be all Americans. So everybody of interest, all Americans. And if I want to study sleep in college students, it would be a population of all college students. So in both cases, it would be very difficult to include the entire population in my research because you couldn't really talk to every American about their feelings on gun laws. That population will be way too large. And same thing, college students, that population would be way too large. However, there are cases where you can get data from an entire population. So for example, if I was interested in what percentage of my immediate family support gun laws, I could easily talk to everybody in my family and get opinions. So if we did collect data from an entire population, that procedure is called a census. So a census is conducted when we collect data from all members of a population. All right, so this is very often difficult or impossible, like in our top 2 cases here. So essentially, if we could, though, that number that describes the entire population, so that measurement, so for example, the percentage of my immediate family that supports stricter gun laws, that percentage would be called a parameter. So measurements that describe populations are called parameters. So describing a population, the value is a parameter. All right, but in these cases, if we're not able to collect data from an entire population, but we're still interested in the parameter, what we're going to do is rely on a sample. So in sampling, we take a subset of our population and we draw conclusions about just the data we collected, the sample. This will be called descriptive statistics. We'll describe that sample. And then the hope is that whatever is true for the sample is a good estimation of what's true for the population. So that process is called inferential statistics. We take a characteristic of a sample and we generalize it. We conclude it's a good estimate for an entire population. So before I continue here with writing definitions, I just want to come to one article here, research that was presented recently on gun violence. So this is from the Pew Research Center report, June 28, 2023. So the title reads, Gun Violence Widely Viewed as a Major and Growing National Problem. And I just want to focus on one sentence here just to give us the idea of parameters. And it says, majority of Americans expect gun violence to increase, public divided on impact of gun ownership on safety. All right, so in particular, the percent of Americans who say gun violence is a very big problem is 60% in the country today. And then the percent who say gun violence is a moderately big problem, 23%, and a small problem, 13%, not a problem at all, 4%. So these values were not obtained from looking at talking to every American. That would not be possible. But based on the sample of Americans they took, we're hoping that these are good estimates for what would be true if we could get data from all Americans. So this information is based on a sample. It says here that they conducted a sample. The survey was on US adults between June 5th and 11th, 2023. All right, so this is our idea of inferential statistics. They took a sample and we try to draw a conclusion about the entire population. All right, so a sample is a subset of our population. And the measurements that are obtained from samples, for example, 60% was it? So this measurement, 60% that say gun violence is a very big problem in the country. That number was obtained from a sample. It is called a statistic. So statistics describe sample data. So I'm going to repeat down here, parameters describe populations, statistics describe samples, and we often have to use statistics to draw conclusions about parameters when we're not able to collect data, for example, from all Americans, from the entire population. All right, so let's just do a couple problems here, just identifying populations and samples and the difference between parameters and statistics. So number one, Rita here is a stats keeper for the local youth soccer league. At the end of the season, she calculated a pass accuracy of 57% for a random group of 25 players. And I will often be highlighting things here as we're reading questions. So we have a 57% accuracy, and that was for a random group of 25 players. In contrast, the pass accuracy for all players in the league was, so for all players in the league, the pass accuracy was 68%. All right, so let's start with our population. So all, you always want to think all. So this would be all players in the league. So all players in the league. And then our sample Rita took would be the 25 random players. Sorry, players. All right, so that pass rate of 57% was for the sample. So 57% is called a statistic. So statistics describe samples. And then the pass accuracy of 68%, that was for all players in the league. So 68% is called a parameter. So I remember the S's go together. Statistics describe samples, and the P's go together. Parameters describe populations. So where it says all there, you're talking about your entire population. Okay, let's try one more here, number 2. Linda publishes a blog on knitting with patterns she has created. Recently, she decided to conduct a poll among 500 of her subscribers and found that 67% of those polled have liked at least one of her blogs. Later, she found out that her website already has information for all her subscribers. According to her website, she has a total of 11,212 subscribers, of whom 72% have liked at least one of her blogs, and they have posted an average of 3.4 comments per blog. All right, so let's start with the population. So population would be all, and we'll just say all subscribers. We could be more specific here and write the actual number, But again, we're just trying to get a feel for this. So there's not exactly one way to write this, but I'll say all 11,212 subscribers. And in the beginning, then the sample that Rita looked at, she did a poll among just 500 of those subscribers, and 67% had liked at least one of her blogs. All right, so her sample is the 500 subscribers polled by Linda. And then the average of 3.4 comments per blog. So that number 3.4. So that described all of her subscribers. So 3.4 is called a parameter. And you can usually, again, identify it's a parameter because if it mentions all, that's the population. And then the 67% of those polled by Linda here, who liked at least one of her blogs. So that was a value based on the 500 she polled. And so that's called a statistic. All right, so that is our introduction here to what we'll be doing this semester. And the first half of our course, we'll be learning descriptive statistics, where we collect data and learn to describe it. And then the second half of our course, we learn this process of inferential statistics, where we use sample data to draw conclusions about a population.